Your goal for today is to identify terms of arithmetic and geometric sequences when the sequences are given in function form using recursive process. So this sounds difficult, but this is not that difficult. It's very easy. What you're trying to do actually is you have a bunch of numbers and you're trying to figure out the sequence between them, or if they have a sequence. That means if they have a consistent pattern. It could be either addition, subtraction, multiplication, or division, and that is what we are trying to find. Now, what you have two different type of sequences. Before we do that, the second thing that you do is that you write the formula for the nth term of arithmetic and geometric sequence given the value of several of their terms. So we would be able to write the formula. You've not been asked to write the formula that much because it could be given to you, but our job is to figure out an equation or a function that goes with it, which is pretty easy because you're basically adding, subtracting, multiplying, or dividing. You just have to look at your numbers carefully. You have two different type of sequences. First of all, the first one is arithmetic. Arithmetic is where you are adding or subtracting. And then second one is geometric, where you multiply or divide. Let's work on the arithmetic sequence first. Arithmetic. The blank between each pair of consecutive term is the same. The difference between each pair of consecutive term, consecutive means right next to each other. So they are first and then second, they're next to each other. That's what consecutive means, next to each other. The way I write my sequences, I like to write them in an organized manner so I can see the number completely. A1, that means this is your first term. So A1, this is your first term because 1 means first. So this is your first term. That means A2 would be second term. This would be third. These are your positions. And this is fourth. So it's better to write them as a table because you are able to see the pattern in the table nicely. So what I'm going to do is I'm just going to rewrite it as a table. So first term, A1, it's 5. So this is term and this is its value. So A1 is 5, A2 is 9, A3 is 13, and A4 is 17. And this way I can actually figure out what are my next terms as well just by looking at the pattern. That is what the sequence is. So in arithmetic sequence, you are going to notice that you are either adding or subtracting. So 5, how do you went to 5 from 9? You did plus 4. How did you go from 9 to a 13? Plus 4. How did you go from a 13 to a 17? Plus 4. So D, common difference, the difference is positive 4. The next term is always found by D. It's a small letter D, which stands for the common difference to the previous term. So over here, you can actually write common difference. And it will work. So in arithmetic sequence, you're adding or subtracting. Now, let's talk about the geometric sequence. So in geometric sequence, you are multiplying or dividing. So the common ratio. So common ratio goes over here. Common ratio, which is small letter R. Between each pair of consecutive term is the same. The next term is always found by R, which is the previous term by the common ratio. The next term is always found by multiplying the previous term by the common ratio. Multiply or divide, but it's divide or multiply. Again, what I'm going to do is I'm going to make a table so I can see my pattern. Super easy. You don't really have to label anything, but you could. This is term because I have 1, 2, 3, 4 terms. A1, A2, A3, and A4. First, second, third, and fourth. And then their values are 5, 15, 45, and 35. So by looking at the numbers, you can totally see that you are not adding this fixed number to it. It has to be multiplication because you're increasing the numbers. So 5 multiplied by 3 sounds like 15. So times 3, and times 3. So common ratio, or R, in this situation is 3. Another way to determine common ratio is you just divide the next term with the previous. So the other way you can do is 45 divided by 15, which is 3. Or you can say 15 divided by 5. You can go backward, and it's also 3. So consistent ratio multiplied by 3. Determine if each sequence in arithmetic is arithmetic or geometric, and then you have to find next 3 terms. So pretty easy. You just have to figure out the pattern. So what you're going to do is make table like that so you're able to see the numbers nicely. And then if you have to find the next term, keep adding or multiplying, subtracting or dividing, whatever you figure out, and you would have the 3 numbers. So suppose if I have to find the next number over here, A5, since I was adding 4, so 17 plus 4 is what? 21. So there you go. I would have my next number. And this way, if I need next 3 numbers, I'm just going to have another, and you would have the answer. So 1, 2, 3, and 4. These 4 examples. Go ahead, solve these. They're easy. You should be able to do all of them by yourself. All right, so the next one is writing sequence given a list of terms. So I have the terms and I have to figure out the sequence, which is extremely easy. You have the formulas given to you. So I'm just going to use the formulas, plug in my numbers, and solve. A of n. A of n means I can find any number, any term. This means any term. So I can find 50th term, 100th term, 17th term using this formula. A1 means first term, so my first number. D again is the common difference. N is the number of the term. And 1 is just the number over there. So given A1 equals 4, A2 equals 12, and A3 equals 20, write an equation for the nth term in the sequence. So first thing I would like to do is I'm just going to use my area over here to write down the numbers so I can figure out the A of n, which I'm going to use this formula for, or the other formula for. This is A of n, and this is the value. So A1 is 4, A2 is 12, and A3 is 20. Look at the pattern. 4, 12, 20. Are you adding a same number or multiplying? Let's check. So 4 times 3 is 12, and 12 times 3 is 36. You're not multiplying. It has to be addition. So it would be 4 plus, this is plus, what, 8? And then 12 plus 8 is 20. So this is plus 8. So common difference is actually, positive 8. Common difference is 8. All you have to do is plug in the numbers in that equation. I need to find an as equation form, so write an, then let me write this way. And then I'm just gonna plug in the numbers. So AN, you need to figure that out, so copy that down. A1 is 4, so instead of that A1, put 4, plus common difference is 8, you put that, and then it is n minus 1, so write an equation in the nth term, and that's it. I have it. And then since I need to distribute, I have the numbers, so I'm going to multiply these two in the next line. 8 times n is 8n, and 8 minus 1, 8 times negative 1 is an 8. You have two like terms over here. Oh, I ran out of space. So AN is equals to 4 minus 8 is negative 4 plus 8n. Or you can write it as 8n minus 4. So this is your function. So all you have to do was plug in the numbers and then distribute, and there you go. You have the function for it. You have one example over here that you have to use the above given formula, plug in the numbers, find the common difference, and you will have the function for it. Let's move over to geometric sequence. So in geometric sequence, the formula is, this is the any term. I can find any term, so this is any term. A1 is again your first term, so first number of that sequence. R is the common ratio. And notice this is in the power, it's the exponent. N is the term number. And this is in the exponent, it's in the power. All right, your given sequences, A1 is 4, A2 is 12, and A3 is 36. So I'm gonna make a table out of it first so I can see my numbers nicely. AN and its value. So first term is 4. Second term is 12. And third term is 36. By looking at the pattern, I know this time I'm not adding. It is multiplied by 3, multiplied by 3. So R is multiplied by 3. This time you do not have a D. It's a geometric sequence, so it has to have an R, which is 3. All right, let's copy the formula from the top. AN equals A1 multiplied by R to the power of n minus 1. A1 is 4 times R is 3 to the power of n minus 1, which I keep it like that. So what this means, since I do not know which number I'm gonna find, I do not know the n here because it could be used for any number. So I just leave it alone like that. But here what I'm gonna do is I'm gonna explain how you read this. So n minus 1 basically means previous term. N means term that you are using right now. And n minus 1 means previous term. So n minus 1 means previous term. This is what it means. So if I have to describe this whole thing, I would say as previous term, 3 to the power of previous term multiplied by 4. 3 to the power of previous term multiplied by 4. And that's it. recursively defined sequences. So these are the formulas that you're already given to you. So you just have to put in the numbers, plug in, and find the sequence. And the ones that you are going to get on the exams are actually easy. You just have to look at the numbers and you're going to find the sequence. But let's work on this one. It says a sequence can be generated by using a of n equals a n minus 1. That means a n minus 1 previous term plus 3, where a1 is negative 3. So if I read the whole thing, and n is a whole number greater than 1, because you already know that every time your n is greater than 1, it starts at 1 and then 2, 3, 4, 5. So it has to be that. What are the first four terms in the sequence? So you have to find first four terms. So I need a1, a2, a3, and a4. This is what my goal is. I have to find the first four terms. I have the first term only, which is the negative 3. So I have to find a2. So use that formula, and this time I already know n is 2. So a2 is equals to a n is 2 minus 1 plus 3. So a2 minus 1 is 1. So technically this is 1. So a2 is when a1 is plus 3, a1 is negative 3. Negative 3 plus 3 is a 0. So your second term is basically 0. Because it was clear. You have a previous term added 3. So previous term add 3 is a 0. So if I have to find the next term, I'm going to be adding another 3. So 0 plus 3 is a 3. I have to find the next term. I'm just going to be adding another 3. So 3 plus 3 is a 6. There you go. I have the next sequence. This is my answer. So I do not have to technically do all the technical math. I just figure out the pattern. I read my sequence, and there you go. That's my answer. So you should be able to do the next one on your own. Pretty clear, pretty easy. And you will be able to write the next 3 numbers on this one. Geometric sequence are the same thing. All you have to do is you have a common ratio, which is already stated to you. So n minus 1 means previous term. So you multiply the previous term by 5. So all I have to do is first copy down my sequence. I have a1, which is 8. I need, what are the first 4 sequence terms? So first 4, this is first. I need a2, I need a3, and I need a4. So according to my formula, I need a2. So a2 is 5, n minus 1, n is again 2, so I should write 2 over here. So a2 is 5 times a2 minus 1 is a 1. So a1 is 8. So a2 is basically 5 times 8. I'm just replacing the numbers. So 5 times 8 is 40. So you technically do not have to do all that work. This can be eliminated if you just understand that 5 is multiplied by the previous term. You just do that much, you read it carefully. 5 is being multiplied by the next term. N minus 1 means the previous. So 8 times 5 is 40. So in order to get the next term, I'm just going to multiply the previous term with 5. So times 5. So next number, I'm again multiply by 5. And there you go. I will have all the numbers. So 8 times 5 is 40. 40 times 5 is 200. And 200 times 5 is, 5 times 2 is a 10. 1,000. So this is my first 4 numbers of the sequence. So just read your equations carefully, which is here 5. In order to get the next number, all I have to do is multiply 5 by previous, and there you go. In order to get the next number, all I do is add 3 to the previous, and I have my pattern. You have 2 questions here, 2 on the top, and 4 on the front that you have to do.